So let's work through the review here. We'll start with the first question. And you're basically asked to do two things here. You're asked to decide what test you would use and set up the null and alternative hypothesis. I'll give you a couple of varieties for this one. But first of all, let's figure out what letter of the test we're going to work with. So you got 6 choices here. You can eliminate a lot of these pretty quickly. We're not dealing with standard deviation or correlation, goodness of fit, test for association. Analysis of variance doesn't fit for us either. And we only actually went over one non-parametric test. Does anyone remember what kind of non-parametric test we went over? What non-parametric test did we practice in section 13.2? Sign test. So the sign test is pretty flexible, and you can use it for testing data and match pairs. You can actually use it for a wide variety of data, but in this case, I would accept a couple different possible null and alternative hypotheses. So one possibility with the sign test is you're testing to see if male and female have the same scores, but the sign test doesn't test mu. Does anyone remember what parameter we test with the sign test? It's the median, right? And the notation I gave you there was eta. So we're looking to see if there's a difference between male and female attractiveness ratings. So if there is a difference, great, they're not the same. If there is a difference, they are the same. So something like this would be possible. If you want to take a moment and just say, all right, well, eta is the difference in female minus male attractiveness, that's fine. Then another possibility, if you redefine things like that, that I would accept is eta equals 0 versus the alternative that eta is different than 0. But please, if you're going to go that route, do take a moment and define for me, what eta represents. And of course, that goes along with letter F. So how are we looking on that one?
Pretty good.
Pretty good? Pretty good? All right. In the book, you find weights in pounds for cola of a sample of cans of regular Coke and cans of Diet Coke. Use a 1% significance level to test the claim that the variance in the volume is the same for both cans of Coke. Well, let's figure out what test we're going to do first. Now, I don't have one that says variance, but I've got something that says something equivalent, right? What letter would that be?
Standard deviation.
Standard deviation has to be A. 2 population standard deviation. So we can do it this way. Mu sub regular equals mu sub diet. Mu sub regular is not equal to mu sub diet. By the way, if you have trouble writing some of these symbols, and I know you're not used to writing Greek symbols, that's fine. You can use eta like that. If you want to just write me a note, say, all right, I know this looks crazy, but that's my version of eta, that's fine. This is sigma, it's lowercase sigma. By the way, eta and sigma are words that you can use in Words with Friends, if you play that. Another possibility here for you, kind of again giving you more possibilities. Testing for the equivalence of the standard deviation is the same as testing for the equivalence of the variance. How do you get from variance to standard deviation or vice versa? Square. So I would accept either one of these. This one is for the variance. The other one was for your standard deviation. Both of them are getting after whether or not there's a difference in the variability there. Okay, let's keep going. Listed below are the heights of mothers and their daughters from a journal kept by Sir Francis Galton. Use an alpha equals 0.05 level to test a claim that there's a correlation between the heights of mothers and their daughters. Should be pretty clear what letter we're working with, right? What letter does it have to be in this case? B. Yeah. B. And again, you're going to get assaulted with lots of Greek letters here. What Greek letter goes with correlation? Good question. There's a couple answers that I'd accept here, but what I was looking for is rho. R-H-O. It kind of looks like a P, but don't put a P here. Please do not put a P here. Why? What does P represent for us in terms of proportion? That's a completely different test, completely unrelated. So P and rho, I might have to mark that one wrong if you put rho where I expected P or vice versa. So, yeah, sorry about that. Don't shoot the messenger. Now, there is another possibility that I would accept there. I'll get to that in a little bit. For now, let's move on to the fourth one. Listed below are the departure delay times for American airline flights from New York to LA. Use a 5% significance level to test a claim that the different flights have the same mean departure delay. Now, I'm not sure, but I wonder if the author has a little chip on his shoulder because he actually said this is American Airlines. I wonder if he's had an experience like many people have an experience with Spirit Airlines. Yeah. Not sure. But this one, you don't even really need to read it too much to know which letter is the correct one. Which letter are we looking at here? E. E. Analysis of variance is the only thing you have that you can deal with that has more than 2 samples. We don't have anything else that can deal with more than 2 samples at a time. It should be mu sub 1 equals mu sub 19 equals mu sub 21. What's the alternative in this case?
One of the above is different.
Yeah, at least one of the above is different. Good on that one? When you test for an analysis of variance, if you're doing it on StatDisk, let me just give you kind of a quick reminder here. Let's see, that's not finding it. Here we go, StatDisk. So if you're on StatDisk, let's close this out. You want to go to analysis. It's one-way analysis of variance. ANOVA is an acronym, kind of a pseudo acronym for analysis of variance. Well, let's continue. I think Kada found the error in this one. Did anyone else find the error in this one? Because the letter that you would need to put in here doesn't exist the way it's written. And the reason it doesn't exist for the way it's written is because really there's only one sample. You have a sample of birth weights of 30 girls. Well, our hypothesis is for testing 2 population standard deviations, not 1. So the way it's written, you should actually be doing something like this. You should say sigma equals 660.2, and the alternative is that has a variance that's greater than that. So maybe I'll say, let's see, sigma squared is greater than 660.2. That's the way it's written. So there is no letter there amongst your choices. On the final exam, all your hypotheses will be in play, so that won't be a problem. But for this one, I probably should have said 662, which comes from a sample, and throw out your favorite number, sample of, say, n equals 32 boys. That would have made it hypothesis tests for two population standard deviations. But as written, it's not. Let's move down to the next one. Are you okay with, or can you see my complaint about the way the problem's written? I mean, it's my fault, but you see my concern here in terms of the hypothesis test?
Yeah.
Good there. Thank you. Dallas, Elijah. All right. Moving on to number 6 here. And let's just do it over here. A little easier to read. Listed below are the duration times in seconds and time intervals in minutes to the next eruption for randomly selected eruptions of Old Faithful Geyser in Yellowstone National Park. Is there sufficient evidence that there is a linear relationship between the duration of eruption times and interval times? There's a couple things that I would accept here. It kind of depends on you a little bit, although there's one that I would prefer as a preference. What we're looking for is a linear relationship, a line. So let me remind you that the line that we fit there is our regression line is y hat equals b1x plus b sub 0. That's your sample statistic. What's the population parameter version of this?
Y equals the funny b.
The funny b.
1x plus the funny b's 0.
Yeah. So basically, again, you've got another Greek letter. This one is beta. And if you remember your algebra a little bit, beta is what in this case? Beta is the slope. Let me remind you about the importance of slope here for a second. Was it this one? No, this one. Here you go. So here's the line, y equals mx plus 3. 3 is your y-intercept. M is your slope. You can have all kinds of crazy slopes. You can have a negative slope, which as you move left to right, the y value is decreasing. You can have a positive slope, which is the opposite. But there's one that's in between that's kind of special. That is if you have a zero slope. And a zero slope means it doesn't matter what the value of x is, the y value is always the same. So knowing the x doesn't really change what you think about y at all. You're just thinking, in this case, y is 3. It doesn't matter if x is 5, or if x is 10, or if x is negative 5. You still think y is 3. If the slope was something other than 0, that would be different. So our null hypothesis here, at least the one that I'd like to see, is beta 1 is 0. There's no correlation, and beta 1 is not equal to 0. This means there is a linear relationship. Now, when we went over this kind of stuff back in section 10.2, one of the things I noted for you, let me just pull it up from the notes I posted online, is that these two things are the same test. StatDisk is not doing anything different from one to the other to perform this test. So if you wanted to write down one or the other, that's fine. They're both testing the same thing. So you could write down rats. Rho equals 0 versus rho not equal to 0.
So could you do that for something like on number 3?
Yeah, you could do that. Now, That said, because I'm looking for a linear relationship, because I actually use the word linear there, I'd be happier to see this one. But I can't really mark it wrong because these things are equivalently the same. I mean, they're the same test.
Because I did the fancy B for number 3, but since they're interchangeable, it would like technically.
Yeah, you could use rho for number 3. You could use beta 1 for number 3.
Okay.
Both of them would work. But that said, I kind of like rho here because here I was looking for a correlation, and that's what this is. This is a correlation. Whereas over here, I wanted a linear relationship. That's more of this line. So kind of leaning this way is the preferred way. That would go along with letter B again. Comments or thoughts on that one? Let's move over to last 2 of these like this. So this is our Kentucky Derby one. A post position of 1 is closest to the inside rail. Use a 5% significance level to test a claim that the likelihood of winning is the same for different post positions. What kind of test is this one?
C.
Goodness of fit. All right, so goodness of fit is remarkably flexible. So that's going to be B. What?
You see?
C.
Yeah, sorry, C. Thank you. What's the null hypothesis going to look like for this one?
P sub 1, P sub 2 all the way to P sub 10 equals 110.
Yeah, basically all those probabilities are equal to 1/10. Our alternative is kind of that catch-all alternative. At least one of the above probabilities is different. Nice. All right. Let's move on down to this one. In a study of high school students, researchers obtained the summarized results below. Use a 5% significance level to test the claim of independence between texting while driving and driving while drinking alcohol. So, which hypothesis test am I going to use here? What letter?
D.
D. Chi-square test for association. Yeah, you want to see if these two things are related. So default is that there's no association, that they're independent. So H naught, we could write that drinking and texting while driving, or drinking while driving and texting while driving are independent. Let's see, do I want to write? I just don't think I have enough room here. H naught, drinking while driving, and texting while driving are independent. The other possibility is that there's an association. So your alternative hypothesis, now you could say dependent. I'd really much rather you putting in the word association. There is an association between drinking while driving and texting while driving. there's a nice follow-up question to that. Now, I don't know if anyone actually put in the data and calculated this, but I'm sure that you're going to get an association. All right, I'm sure you reject H naught. Can the results of this study be used to support the claim that being drunk causes risky behavior like texting while driving? Got a couple shakes of the head. Why not?
Association does not indicate causation.
Yeah, quite simply, association is not the same as causation. So that's really what the point that I'm getting to is. Association does not imply causation. And if there was a cause and effect relationship, which one causes the other one? I mean, might be that texting causes drunk driving. Who knows? We can't prove causation with this kind of a study. All right, let's keep going. Problem number 10. I would probably work on problem number 10 like you would the SAT test. So what you want to do in problem number 10 is try and figure out which one of these is the right linear correlation coefficient. Probably the best thing to do is to start out with the easiest ones, right? Let's get the easiest ones. Starting out with this one. What's a linear correlation coefficient like for a straight line like this?
-1.
-1. So let's scratch that one out. How about this one?
+1.
+1. What's another one I can knock out pretty easily?
Half circle 0.
0. There is a relationship here, but it's not a linear relationship, so it has a correlation of 0. Another thing that would have a correlation 0 is if I had just a wild scatter of plots, points that was completely random. So that leaves us with a couple possibilities. We have 0.88 and 0.22. Both of those are positive. Which one is that going to go with? B or E? E. So it has to be one of these. Which one feels more likely, 0.88 or 0.22?
0.88.
0.88, because that's closer to a line than this would indicate. Finally, we've got negative 0.91 and negative 0.31. For this one, we've narrowed it down to two choices. Which one looks more likely?
9.
Yeah, negative 0.91. Nice. Onward. I seem to think your author really likes this problem because it's appeared in a couple editions of his book. Using data for pizza costs and subway fares, this is in New York City, we fit this regression. Y hat is 1.01, x minus 0.11, x is your pizza cost, y is your subway cost. Use the regression line to predict the cost of subway fare if the price of pizza is $2.20. Okay, now there's one thing that's important to notice here. I'm asking you to assume that you rejected H naught at the 5% level. So if you do that, what are we going to do in order to predict the cost of a subway fare if the cost of pizza is $2.20? How am I going to make that prediction? Somebody said it.
We're plugging it in.
Yeah, just plug it in, right? You've got a nice equation. So y hat equals 1.01 times x minus 0.11. Here they're telling you that the price of pizza is $2.20. So I'm gonna put that in here for X. So Y hat equals 1.01 times $2.20 minus 0.11. I think we get, what, 2.112. Now, of course, you could round that off to $2.11. I'm not sure if they ask you to or not. But you do need to, or you could round it off. This is the exact one. I'm not going to worry about whether or not round it off. The only reason I'm rounding it off is because we don't have anything like a tenth of a penny in our currency. So that's why we're rounding it off. Now, I included this next part for a reason, because it's easy to forget, and I wanted to remind you of it. Use the regression equation to predict the cost of subway fare. Assume that we failed to reject H naught. How's that going to change our prediction here? Our Y hat. Ah, well done. So again, let me look back for you at the notes we did in class. So there's two possibilities. For your predicted value, you're either going to use the regression line if you rejected H naught, or you're going to use the average value of Y if you fail to reject H naught. So one of those two. In this case, since we failed to reject H naught, we're going to use Y bar. Y bar is just, well, Y bar is given for us, but what did I have to do to find Y bar? What do you think? Yeah, just add them up, divide by 6. So Y bar is 1.083. Now, not a bad thing to do would be to go back and take a look at that weather homework, that in-class regression assignment that never exactly quite came to be like I wanted to. But one of the things I asked you to do was interpret the slope of your regression equation in words. So let me write that slope down again. Y equals 1.10 or 1.01x minus 0.11. X is the cost of a piece of pizza. Cost of pizza. Y is the cost of a ride on the subway. So what does that mean the slope is interpreted as? How would I interpret that in words? There is a nice correspondence there. I'm actually looking for something a little different. What would happen to the cost of a subway fare if price of pizza went up by $1? How much would the price of a subway fare go up by? For every extra value you have here, for every extra unit you have here, price of the subway token is going to go up by that much. So for each extra $1 in cost for a slice of pizza, subway fares increase by $1.01. So that's a nice interpretation of, the subway, or excuse me, of the slope here. And that's pretty much what I'd want you to do for like all of these things. I think one of the examples I gave when we covered regression was something like this. Y equals 19.2x, I'm just making up a number here, plus 350 or something like that. X was the number of days that I've owned my car. Y is the number of miles that I had on it. So what that's saying is that for each extra day I own my car, I put another 19.2 miles on it. So that's the kind of interpretation I want from you for the slope. Okay, last one here. Coefficient of determination below is 0.9025. This is coming directly off of your in-class regression assignment. Coefficient of determination, does anyone remember the notation for that? What would you see it listed as in the output on StatDisk?
R squared.
R squared. So what I've got is R squared equals 0.9025. Now the rest of this I could almost give to a class in algebra. It asks us for the linear correlation coefficient. There's an extra parenthesis, or there's an extra question mark in there. Linear correlation coefficient, that's all one term. Does anyone remember the notation for the linear correlation coefficient?
R.
That's R. I don't know why they chose these names to be such mouthfuls. They did. Again, don't shoot the messenger. But if I'm looking for R, and I've got R squared, what do I got to do to get R squared?
Take the square root.
Take the square root. Except that if you gave me 0.95, I'd be unhappy. I'm not sure I'd give you credit on that or not. I don't know. I'd have to think about it. What might be my complaint about this?
It's negative.
Yeah. Because the line has a negative slope, you would want to choose the negative of these two. There's two square roots, one's positive, one's negative, but in this case, because the slope of this is negative, you'd want to choose the negative slope. Don't forget, as you're preparing for this thing, to look up 5 ways to prove causation. Know the difference between weather versus climate, and know what a confounding variable is. Now, when we did these tests, we didn't actually finish all the work there. It might not be a bad idea to go back and finish the work, do the hypothesis test, all the way through, decide if you're going to reject or fail to reject, write your conclusion in words. Kind of like the previous test, I will give you, where is it? I will give you the wording, the hypothesis conclusion sheet, so you will have that available to you, but you have to know how to use it. Anything else?
Yes.
No? Yes? Go ahead.
For C, would total cost in some way decrease instead of increase?
No, because you have a positive slope. So that line, if you were to graph it, would be positively sloped, and when you increase X, you're going to increase Y.
But if you plug in one,
Tell you what, let's do just that. So, let me shut this off and do a little table here for ourselves. Let's see, we'll do f of x equals 1.01x minus 0.11. So let's start with f of 1. F of 1 gives me 90 cents. If I go to 2, now f of 2 is $1.91. F of 3, F of 4, F of 5, it keeps on going up by $1.01 each time. So what's happening is as you increase the slope, as you add 1 to the value of x, you're adding 1.01 to the value of y.
Oh, I saw your 1.01 when I put in like the one, I got 0.9, I got confused.
Okay.
That's a different one.
All right, appreciate you asking.
Question about number 9.
Question about number 9.
Have a good weekend.
2.
Is it bad to say correlation is not equal causation instead?
That's okay, it's getting at the same thing.
Okay.
Basically, what I wanted you to be aware of here is that correlation is not causation.
Yeah,
So
okay.
we can't draw those kinds of conclusions from this kind of test.
See ya.
See ya.